Hello, and welcome to the fifth and final episode in the Making 2048 in Python series. In this episode, we're just going to make sure to complete the finishing touches to make sure our game works properly. And in the last episode, we covered the shifting, which did take a while, but that was the main component of our game. If you haven't seen that, then you definitely should. And so we'll begin. So when we run our game, everything in terms of the main functions are working properly. So you'll see that the shifting works and merging works and all of that. And obviously it generates well and the grid prints out properly. However, one thing you'll notice is that whenever we move, let's say, I guess here we'll move right, but then let's say here, you'll see that if we move right again, nothing in the board will actually change because none of the numbers can actually move right or merge right. And as a result, in the real game, what should happen is that no new number should be generated. But if we do it here, you'll see that even though none of the numbers move, a new number is generated. And we want to try and avoid that. So that's the first thing that we should work on. So let's go to our code and scroll down to the game loop. And so essentially what we're trying to do is generate a new number only if shifting has been done. So only if numbers have moved. Now, this is a bit hard to implement because essentially we don't know, we don't know whether the grid will move. It all depends on the placement of the numbers and what numbers are on the board. However, one of the ways we can try and think about it is saying, well, if none of the numbers move, that basically means that before we shift, so before we enter a W, A, S, or D, the grid should be the same as after we shift. So basically after we enter W, A, S, or D. So a simple way of going about this is comparing the grid before the shifting and the grid after the shifting. And then based on that, if the two grids are equal, then we can generate a new number. And if they are not, then we don't generate a new number. So what we can do is, I'd say first, let's try to save the grid into a temporary grid. So since we don't know whether these shifting methods will change the board or not, we should save the grid beforehand so that after the shifting is done, we can compare it with the saved grid to see if it's changed or not. Okay, so the way that we can create a temporary grid, so essentially make a duplicate of the current grid, is, let's say temp grid is equal to, for now, let's keep it like this. Okay, so let's keep it like this, and then actually let's make, since our grid is a 2D array, let's make this a 2D array as well, because they should have, the temporary grid is just going to be a duplicate of the current grid, so we just need to make sure that they're the same. And then let's fill it with zeros for now. And again, we're putting 4 numbers inside each inner array, since that's how many numbers that are in the current grid. So yeah. Okay, so now what we need to do is go through every number in the other grid. So yeah, so this grid, and copy all the numbers into our temp grid. So since we have to go through every single number, it makes sense that we'll be using a for loop. So let's say for, and then our outer for loop, if you remember from like the shifting, is going to basically be our row. So for row in grid, or range grid, or sorry, it should be length of grid, because yeah, length of grid will give us 4, since that's how many inner arrays there are. So that means row will be 0, then it'll be 1, then 2, and then 3. And then for a column in range, length of grid of 0. So yeah, so our outer for loop is going from 0 to 3, since that's how, that's basically the length of, that's how many rows there are. There are 4 rows, so our variable row should go from 0 to 3. And then our column will go from 0 to 3 as well, since there are 4 columns. So yeah, you can also, instead of doing length of grid, you can just do 4, and you can just do 4 from here. Either way works, since obviously they're both equal to 4. So yeah. Okay, so now we just need to copy the grid, or the number from the grid into the temp grid. So I'll just do grid, row, column is equal to temp grid, row, and column. Okay, yeah, so basically we just looped through every number in this grid and copied it into our temporary grid. Okay, so now we saved the grid before we did the shifting, and now we just need to compare if the temporary grid is equal to the regular grid after the shifting has been done. And the way that we do this, it's basically going to be another function, right? Since the function is going to be comparing the 2 grids. So we can create a new method for that, and let's call it let's call it compare grid, and it'll take in 2 parameters, since there are 2 grids that we're trying to compare, and we can call the variables grid 1 and grid 2. And then again, we just need to loop through every number in the grid and then check if they're equal. So it's going to be the same for loops as what we did below. So yeah, column in range, and yeah, again, we can just put 4 instead of typing it all out, since we know that the number of rows are 4, and we know that the number of columns are 4. We can just type in 4 instead of having to type in like length of grid and stuff. Okay, so now we just need to check if grid 1 row and column is equal to grid 2 row and column. Okay, so actually, instead of doing equal to, let's do not equal to. Because the reason is we do not equal to instead of equal to is that all we're doing is checking for any number in which the two grids are not equal to each other. Because, if only one cell is different between the two grids, that means they're not equal to each other. So if they're not equal to each other, then all we have to do is we can just return false. Okay, so essentially we're just going through every number in two grids, and then if any cell doesn't contain the same number, we just return false, because that means the two grids are not equal to each other. Okay, so now we can just say if and then just one other thing is that we also need to remember to return true at some point, and in this case, if we looped through every single number and they're all equal to each other, so basically if they never return false, then we'll just return true. And so now we can just do if we can call our method, so compare grid, and then our two grids are called grid and temp grid. And so if that is equal to true, then we'll generate. Okay, and then I think one thing is that here, I just realized we should actually switch these two around, because we don't want to copy what's in temp grid into our regular grid. We want to copy what's in our regular grid into our temporary grid. So let's change that right now. Just always remember that whatever is on the right is being put into what's over on the left. So in this case, the grid is being saved into our temporary grid, which means the grid should be on the right-hand side of the equal sign, and temp grid should be on the left-hand side. Okay, and then just one last thing before we run it, is that I think down here we put true instead of false, and we want to keep it false because, we only want to generate if shifting has happened. So in other words, if the grid has changed. So if we put true in here, then it would only generate a new number if nothing happened. So if the shifting didn't happen, which is basically the opposite of what we want. So instead of keeping it as true, we'll put it as false. Okay, so now if we run, we'll see. So let's try shifting it down, or let's just try shifting it right. And it works. Okay, now here, if we shift it right again, it should not generate a new number. So let's try it. And you'll see that since nothing was able to shift, we don't generate a new number, which is good. But let's say if we do shift, if we are able to move, a new number does generate, which is good. Okay, so that's one of the things that we needed to finish so that our game would work. Now, another thing that we should do is essentially, if we ever get to a number that's like very big, so let's say we get to like 128 or 1024, what's going to happen is that some of the numbers are going to look very close together, or they're not going to be aligned essentially. So I'll try to show you right now. Okay, yeah, here's what I'm going to do. I'll put this in just to show you. Yeah, you'll see that if we ever get a big number like 1000 or 128, you'll see that everything is shifted so that they're not in the same, or they don't look like they're in the same column anymore. And that's because when we have a larger number, but we keep the same spacing, what's going to happen is that there's going to be a bigger, or the alignment is going to be off. And so one way to fix this is to change the spacing based on how big the number is. So let's say if the number is 2 digits long, we only want 3 spaces. Or if it's 3 digits long, we want it to be 2 spaces. And if it's 4 digits long, we want it to be 1 space. So yeah, we can do that right here. So let's create a variable called n space, and let's make it 1, 2, 3, 4, because that's how much the spacing should be if it's a single digit number. However, let's say if grid, so if the current number is greater than 9, which basically means if it's a two digit number, then n space should instead be 1, 2, 3 spaces long. And let's just copy and paste this this many times, and then here we'll put 99, and here we'll put 999. Let's make this 3 spaces, so 1, 2, 3. And then down here it should be 1, 2. Or sorry, up here it should only be 2 spaces, so 1, 2. And then down here it should be 1 space. And then instead of setting the end to be equal to 4 spaces, let's just set it to be equal to n space. Okay, let's try and write it now. Okay, yeah, so here you'll see that if we keep that 128, everything else is still aligned, which is good. It makes it so that it's still clear what's in a row, or what's in a column, right? So they're still all aligned, which is good. So yeah, essentially what we did is based on how large, when we're printing the grid, based on how large the current cell that we're looking at is, we'll change the spacing so that everything is still aligned. So yeah. And yeah, so those were like the main points that I wanted to cover. Basically, right now our game is at the point where all the main functions are done. And we even got some smaller functions, so making sure that everything is aligned. And yeah, I think that's where we'll end this episode and the series, actually, since we got everything done. And yeah, if you want to add more elements, so one of the things that we didn't do exactly was add in an end game. So like once the board is filled and nothing can be moved, the game should end. But I think that if you have the skills necessary, that if you've learned skills, you can incorporate that in your own time. And again, if you ever need a refresher, the first episode, we covered all the basics of Python. So I highly recommend you review that if you're trying to add more features to the game on your own time. But yeah, that's going to be it for this episode and series. Thanks for watching. I hope you like and subscribe, and I'll see you next time. Goodbye.